Hello, everybody. My name is Virginia, as you heard, and I'd like to do some, first would like to present agenda for today, and then proceed with the presentation. So what is that we're going to learn today is, first we will start with introductions. I will introduce you, the audience, myself, and the sensitive data, the three main players. Then we will cover some security framework and roles of the DBA and developer in the organization, cover the threat classification, external, internal, and naive threat. And we will focus on internal threat after that. We will proceed with sensitive data definitions to understand where the threat appears. And then we will talk about how we prevent the threat. We will talk about the tools that Microsoft SQL Server provides us and tools that it doesn't. And the tools that Microsoft SQL Server provides us for that specific category of threats are encryption and data masking. And in encryption, we will cover the definition of encryption, the algorithms, and I will do hands-on demo on implementation of AlwaysOn so that you can see firsthand how it's done. Then I will proceed with data masking. I will explain to you the difference between static data masking and dynamic data masking. I will cover Microsoft dynamic data masking implementation. I will explain who is the recipient, how it connects to identity access management. I will explain the architecture, the algorithms, and implementations, cons and pros, and I will show it also hands-on. And then I will explain how you can implement static data masking with and without Microsoft tools. So I will be asking you to collect the questions for the end. I will cover them if we have some time left, or in the blocks coming up after the security chapter. I just did the presentation on the other chapter, fundamentals, and I will just gather all the material and post the blocks on the site. And with that, let's proceed. So the first thing is introductions. Let me introduce you, the audience. Me, I'm Virginia Mushkatblat, the founder of HushHush, data masking company. And the third is the sensitive data, important component of our today's presentation. And this is what we're going to be talking about. Not about you, not about me, but about the sensitive data. And in order to talk about sensitive data, we need to understand, first of all, the threat classifications. Why threat classifications and why sensitive data at all? The thing is, why do we protect data? Because there are hackers out there, and hackers come in different flavors. And because they come in different flavors, you protect against them in a different manner. You protect from the hacker. When people think about hacker, usually they think about a person from outside, malicious outsider, who comes and breaks through the perimeter into your databases and tries to figure out how to get all the data that he can, so that he can sell it or she can sell it on the black market. But majority of the threat usually comes not just from hacker, but from other categories of the data users. About 36% of the breaks, according to the Panama study, come from inside. And they have to do with what we call malicious insiders. So the second type of a threat is the malicious insider threat, the thief internal threat. And internal threat also comes in different flavors. There is the person at the very top of the organization who will do trade secrets or do internal trading on the stocks with the internal knowledge. And these people, you can't really protect data against them. They need to see the data as it comes. The only way to protect against the malicious insider in the CXO office is to do contractual. However, there are other people in the organization who also might have an interest in data, in order to either sell it or sabotage the organization. And sometimes, just for the purposes of having fun, people drop the necessary data or change it. So who are these people? The production user is the one who is using your applications. They don't usually have access to the database. They have access to the applications only. But even in the applications, they can do a lot of harm. They can learn credit card numbers, social security numbers, and either can apply for credit card with your information, or they can just sell data on the black market. Credit card number goes for $7. Actually, your insurance number goes for much more. The healthcare threats are significantly more expensive because the healthcare industry is less protected against the fraud. There are DBAs who rarely sell data on the market because honestly they're so exhausted and work such long hours. For example, myself, as I was a DBA, I was spending 24/7 for support, and I rarely had any free time. Not that I have it now, but but you all know what I'm talking about, I'm certain, since you are here online with us today. And then there is, of course, a developer, and they also have access to your data. And all three categories of people, you protect data against them in a different manner because they have different way of accessing your data, and they have different roles in organizations. There is also another type of a threat, which is not the focus of our today discussion, but it exists, and this category is naive hacker. It's an unintentional insider who doesn't suspect the threat is coming, clicks on the links in the emails, or takes the USB stick off the floor and sticks it in the computer, introducing viruses or trojans and allowing your data just to leave the organizational perimeter and get into the hands of a real hacker. But today we're focusing on internal threat, and we are going to talk about what sensitive data is. So let me introduce the sensitive data. How do you know which data is actually sensitive? You have a lot of fields in your database. Which part of it, which subset of those fields create the sensitive data model? It will very much depend on your industry. But not only that, it also depends on what data there is in public use. Because the very definition of the sensitive data is data that can expose your privacy. It's data that people try to hide, or at least to hide in the context. Everybody has a record in the public records about their name and date of birth, and it's an exposed information. However, within the context of the organizational use, this data might require some privacy. And recognizing that, there were a lot of compliances in different industries, such as health, financial, e-commerce, education, and government, that mandate you to not to expose sensitive data. For example, there is a privacy rule and transaction and code set rule, the security rule, the unique identifiers rule, enforcement rule in JLBA. In HIPAA, there is a safe harbor model definition that requires you to cover specific data fields. So if you look how you define the sensitive model, I would like to introduce you the originator of the field, Latanya Sweeney. She has her own website, and if you go onto your website, you will see how easy it is to identify you, knowing just three elements of information: your age, your gender, and your zip code. Go ahead and try to play with your tool. You will be surprised how easily you are identified by knowing just these three pieces of information. She came across the interesting problem when she was young and a graduate student. She watched Governor Wilson to give a speech on a stage and fall, And she went into Governor Wilson database and looked at the diagnosis. She was able to identify Governor by 3 elements of his origin: the age, the gender, and the zip code. And thus she discovered that data model not only needs to hide the social security numbers, passports, social insurance numbers, or driver license numbers, which are unique to you, but also what she called non-unique identifiers, and those are the elements that are not directly identifying you, but in combination can expose your identity. And she created what we call 18 elements of a safe harbor. Safe harbor is if you don't know how to identify sensitive model based on the data in your application, to do your own expert determination, you have to maintain at least those 18 elements. And there is much more to talk about in the expert determination, because sometimes 18 elements are not enough. And you need to look at what exactly data you have in your application and whether there are other public sources of such a data that can expose it. But when you identify your sensitive data model, now it's time to look at how we hide these sensitive elements and whom we are hiding them from. And we have decided that we are hiding them against the internal threat, and that means we will be hiding data from administrator using Always Encrypted, hiding data from the user using dynamic data masking, and hiding data from the developer. And for that, you will need the static data masking methods. And only 2 methods are implemented by Microsoft, and both depend on the identity management mechanisms, as they define privileges of the people who can access the data first, and then either hide the data or keep it open to the eyes of the consumer. The implementation of each method differs, as they were not done the same way, and I will explain why when I will be discussing each. But the fact that Microsoft didn't agree on the implementation consistency will bring significant difficulties for you in the decision making. And I will also explain why as we progress with the presentation. However, some of the methods do have advantages, and we will also discuss them. Static data masking is not implemented by Microsoft, although it's absolutely essential in hiding data from developers. And I also provide you with examples and explain how you can implement it. In my further talk, I will be assuming that we're all familiar with the various ways Microsoft handles identity management, and that we are all familiar with the definition of privileges based on the securables and principals. And as you know, securables are the resources that principals get authorizations to. We also will assume that we know, if we don't use the SQL Server authentication, that we all know how to authenticate the person with Windows authentication when the account comes from Active Directory, for example, or any other identity management system. Identity management is not the focus of this presentation, but it will be part with the user's roles and privileges for every single demo. So let's dive deeper into those methods, shall we? And we will start with encryption. Let me define what encryption is, and I will read you the definition. Encryption is the process of encoding messages or information in such a way that only authorized parties can read it. Encryption does not of itself prevent interception, but denies the message content to the interceptor. In an encryption scheme, the intended communication information or message, referred to as a plain text, is encrypted using an encryption algorithm generating ciphertext that can only be read if decrypted. For technical reasons, an encryption scheme usually uses a pseudo-random encryption key. But we don't stop with encryption only. We also introduce what we call authentication. Because encryption by itself only protects the confidentiality of messages. And other techniques are needed to protect integrity and authenticity of the message. And oftentimes we introduce verification of a message authentication code with MAC. And Microsoft used encryption and authentication algorithm, which they called AEAD_CBC_HMAC_CH8_CH8_256. This stands for authenticated encryption with AS, CBC, and HMAC, SHA. And what you can do to get into very details of it, you can go into Wikipedia and read on AES first, and then go into the website on the very bottom, and there is many pages in explanation. Not explanation, there are many pages standard for that particular encryption mechanism that Microsoft is using. But in general, I'd like to say what this letter stands for. And AEAD is authenticating encryption with associated data. AES stands for Advanced Encryption Standard, which is by far the most secure right now, based on the NIST definition. And CBC stands for cipher blockchaining and refers to the generally known algorithm. When you take parts of the plain text, you create an initialization vector, introduce it in the beginning of the algorithm, and then using key to block cipher encryption into ciphertext. And you iterate till you consider the resulting message secure. I don't know about you, but I learned first time about ciphertext from the books of Sherlock Holmes. In his story, Dancing Man, he introduced the very first example of the codec based on frequency of the exposed letters. So when I teach at universities classes that use some kind of a coding mechanism, either the security or multimedia, I always introduce that example of Dancing Man. And oftentimes with Zora, I find out that I'm the only one who actually read the story. So, so they have some classroom reading to do also. Okay, so after a cipher blockchaining is applied, we also apply the HMAC SHA, message authentication code, and secured hash algorithm to allow for verification of the message authentication. Moving on. And now I'd like to ask you to look at demo of Always Encrypted. And I would like to switch the screens. Robert, can you see my screen?
Yes, seeing SSMS right now.
Okay, that's good. All right. Here I am. So far, so good. What I will be doing, I will be showing you AlwaysOn. AlwaysOn encryption is a new method of encrypting data by column with two types of algorithms based on roles that store keys in the client side. And not the way we do it with the master key and the key when we store master key in the master database, but rather the keys are stored on the client side. And it is achieved by allowing for always encrypted enabled driver that's installed on the client computer. So always encrypted allows client to encrypt sensitive data inside client applications, and it never revealed the encryption keys to the SQL server. Client is in charge. You will need that method if you want to encrypt data so that it's not accessible by DBAs. For example, you outsource your DBA functions, purely DBA functions, and people just need to do backup and restores, maintenance, and they absolutely don't have a need to do any development tasks and have access to the data. So what you will do, you will use Always Encrypted. So the driver encrypts the data in sensitive columns, just columns, before passing the data to SQL Server, and then automatically writes queries so that the semantics to the application are preserved. Similarly, the driver transparently describes data stored in encrypted database columns, right, that are contained in query results. So let me show you now how it's done. Right now, I will use the master database. I will create, let me see how we are on time, sorry. We will create the encrypted DB, and we will create a simple table that only has name and social security as the fields, columns. I think it takes time because I'm actually working with the webinar, so the resource is taking some time to do. It says we are using it. Okay, so let me kill the user. Must be who first. Well, let's find out who's using the database. It's me, of course, but I don't know under which ID. So let me get rid of me. Okay, let's try again. Okay, now we succeeded with the killing the database and creating the database. We are good. We are killing nobody now. So let's use encrypted DB and create a table. Here we go. And we have encrypted DB, and if we refresh the tables, we will see the table here with sensitive data and with the columns. Very nice. Now, let's insert something, one record only, with my name, two records actually. My name and Robert's name. Robert, you are now in the table. Let's check if it's true. Yeah, it's true. And what we're going to do now, we are going to put the encryption, AlwaysOn Encryption, on one of the columns. And for that, I will be using SSMS as a client. And I will go into database. Right click on it, go into tasks, get into encrypt columns, which is 2016 feature, and in there we will see columns that are presented for the tables, and one of them will be name and another one will be social security. I will let's say encrypt name, and what I have to do, I have to choose a type of the encryption. And we have two types. One of them is deterministic and one of them is randomized. Randomized will always present you with the random result of the encryption. Deterministic, however, will not present you with a random result. The result of the encryption will always end up with the same value. Randomized is more secure, but deterministic is more useful if you need to preserve values across the database. I will choose deterministic right now, and then proceed. We will choose this to store the key, generate the key, which master key will go into the Windows certificate store. If you're in Azure, it will go into Azure Key Vault, a specific place for the keys in Azure. And then, and the master key source will be the current user. It will see that there's a current user. And we will proceed to finish. Right now, the master key, the keys that encrypts the key, is stored in the client, and the columns are being encrypted as you go. Robert, do we have any questions as of now?
Yes, we have one question right now. Kiran Patel asks, if someone wants to know the value of the encrypted column, how can they decrypt that column?
Okay, you will have to have the proper role, the proper privilege, and I will show you how to see the decrypted values in a second. I just need this thing to finish, because the go to webinars takes all the resource of my computer. Apparently, it takes some time to finish that thing. But honestly, it depends on your privilege. What you will do, if you're going to be a client, you hold the key. So what you will do, you will create an option that says the always on enabled. And with that value, the driver itself, when you connect to the database, the driver itself will decrypt based on the keys that you provided from the external storage. It will decrypt the values and it will present to you in decrypted value. But if you're a DBA and the client doesn't want you to know the value, you will never know it. Well, unless you can break the algorithm. I wouldn't actually do that, because I am not up to the task, but some people did. Genius did actually. So my current login is created, and it has currently data reader permission with the test login user. And if since we applied that data, we will select, okay, I cannot do because principal doesn't exist, so I have to create, yes, because I dropped the database, so I have to create the user, sorry. So right now we have it. And now we will want to retrieve data and it's decrypted. So when we protect the columns, now that you're in a database, you cannot see it. Now, how do we do as a client? How do we see value as a client? For that, what I will do, I will change my connection and present myself as a client to the database. SSMS is a client connecting to the database. So in the changing connection, I will go into options and I will say that my client will have additional connection parameters. If you are using other application, you will have to pass this option to the driver as well. Okay, so I will connect with the parameters enabled, and I will try to execute it as a client now. As you can see, as a client now, I can see the values of the name again. So as a DBA, without the option enabled, you cannot see values. As the client, you can. Okay. This is the always on encryption. It will show you the complete schema. It will select all the columns. You will tell which columns you actually want to encrypt or decrypt, or and either you want to use deterministic function or non-deterministic function. Going back to the presentation, we will look at the data masking now, because I have another like half an hour which I can talk. I can fill a lot of stuff with data masking. This is what I do. So classic data masking definition actually is that a process of masking specific data elements within data store while preserving data look and feel and usability in applications. Meaning, you take the data element and you fake it with something. But something has to have the same rules. If your application checks credit card validity, you better have a LAN number preserved. Credit card is a number that consists of a certain amount of digits. The first digits are the issuer. The middle digits are your PAN, the account number, primary account number. And the last digit is calculated based on a LAN algorithm. It skips every second number and adds them up together, making it checksum. And if your application, if you're, for example, a financial application that does allows people pay with their credit cards, and you need to make sure that credit number that comes to your application is a proper credit number, your LAN number has to be preserved. Because when you develop, if you don't follow the rule, the application will break. However, Microsoft coming up with the dynamic data masking explained that it's actually not the real, not the static data masking, but the dynamic data masking, and it's used for different purposes. So the first method appeared in the late 90s, and with the first regulations coming out and significant development of outsourcing. It changes data statically and irreversibly on the disk. Implementation of static data masking is very challenging. It's not easy to do, as it requires preserving key anonymity. Remember this Latanya Sweeney girl? She was the one who came up with the concept of key anonymity, which says basically that the combination of data elements will provide you with a certain amount of certain amount of the ability to be uncovered. That probabilistically you can be re-identified. And the key anonymity preservation is in such that non-unique identifiers and public data in every one use, the developer would not be able to re-identify the data. Basically, you have to pay attention not only just to unique identifiers, but to non-unique identifiers. On top of it, your application has to preserve referential integrity so that you can't just randomly change data. You have to maintain data within specific range. So deterministic masking is also important. And over time, there are many algorithms. There were many algorithms that appeared, and we will cover some as we go into static data masking. But right now, concentrating on a dynamic data masking. Somewhere later in the years after 90s, Informatica pioneered dynamic data masking. They first came up with the patent that allowed them to integrate into the protocol for many database vendors and change the data on the fly. It's not, they didn't do it in the driver, but right before the driver connects to the database in the protocol, they have a utility that reads the protocol, as you know, the SQL Server protocol is a tabular data stream. You can identify internally the elements, and if these values were the ones that metadata corresponded to the ones they considered sensitive, they would change the value. And this allowed them to preserve the application layer with the data on the disk staying intact. So everything changes just an application layer in between the disk and your application. A lot of other vendors followed, but if they would be implementing dynamic data masking in Informatica way, they would be impending on the patent. So you have to be aware of any vendor who says they can do it in Informatica way. Microsoft, being aware of that, came up with another patent and a version of dynamic data masking. And this version is the one based on schema modification. It is a great way for some applications with sensitive information, right? But it's not without its problems. So let's first see what we can do with the Microsoft implementation. We will look first at the algorithms that Microsoft is using. Microsoft is using two major algorithms. One of them is character substitution, and the second one is number variance. In the character substitution, there is a generic algorithm which is called default. And it takes all the string data types, but the ones with max, and replaces the string with 4 access. Or if the string is less than 4 access, it will with less than 4 characters, it will replace it with the less than 4 access. It will take numeric data value and replace it with 0. Date it will replace with the, for some reason, January 1st, 2000. I don't know why they chose this particular number. Maybe for them the computing age started in 2000. I don't know. And in email, they will take the value of email and end it with the domain.com. So these four algorithms that Microsoft is using in on-premises solution that I will be showing you today use what we call character substitution. They also have a credit card number specific algorithm that they use in Azure. Number variance algorithm is a bit different. It allows you to change the value of any numeric type to a value in a specific range. And I'd like to get into a hands-on demo now on dynamic data masking. Everybody can see the screen, tell me. You can see the SSMS again.
Yes, we see it.
That's okay. So we will switch to another database, which is called security database. And there I will be creating a patient table, which will have 5 fields. The ID, which we will not mask. Name, which is a var character 20. Social security number, with varchar 11, so it has dashes in it. Profit. I actually was thinking maybe I should use debt. But then I decided that is very pessimistic. Who wants to think about that? So I decided I'll take a profit as a numeric value. And then I will introduce my own email, so you can remember it later on. So I will insert patient with my personal identity. I will use Virginia. I will not give you my social security number, but there is no need. And I will say that I have a profit of 2,000. It's a nice, sizable profit. And I will introduce my email, which is virginia@maskme.net. And let's do it so. All right, so we have inserted one record now. Here I am in the database. Now let's apply algorithms one at a time. In order to apply algorithms, if you already have data in place and schema in place, it's not an easy endeavor. Actually, now you have to go back into schema and you have to find the table that you would like to apply the algorithm on, and you will have to alter the schema. Remember, Microsoft had to implement the dynamic data masking into the engine, which they did. So what will happen, I will be applying the algorithm one at a time to every column that I consider sensitive, and I don't want to be exposed in this particular application. Let's do it. See you. Pardon me, I didn't mean to. Something happened. I will have to do it again. Oh, I apologize. I think it switched my permission. Yes, I have to find myself. Pardon me. Let me revert. Tells me I don't have permission for the patient. I would like to reconnect them. And you know why? I know why. Let me try again. Still doesn't let me do it. Okay, because I'm in a different database. That's why. All right, coming back to security database, let me try from the beginning. Very good, I'm in. You know what happened? I wanted to tell you about it at the end, but I'll tell you now because you have seen my failure. And it's not my failure. Microsoft doesn't allow you to combine to combine dynamic data masking and always-on encryption. And this is one of the biggest fallacies of their current solution. Sometimes you will need to protect data from both, from DBAs, whom you outsource your data to, and from developers, whom you may also outsource your data to, at least some of it. So in this particular case, you are out of luck, because you can't do both. You cannot do both always-on encryption and dynamic data masking. And remember, dynamic data masking is not for the developer. Dynamic data masking is for the user. So if you outsource your application administration to some third party, and the user still needs to cover sensitive data, you will have to come up with a different implementation, because it won't allow you to alter the tables. You just can't have it masking and always-on encryption together. But I successfully applied the default algorithm. Now I'm going to apply the partial one, and random for the profit. Hopefully it will make it more. In the random, I chose profit from 1,000 to 10,000. And I will apply the email algorithm. Okay. Now, after application, let's see what I can see. Because I am still the proper user, I can see the data as not masked data. However, if I go and create a test login user in the database, I already have it in my logins. So I'll create a test user login in the database. Okay, so I have created it already, and execute under the security context of text login. I will see a very different picture. This is what your user will see when she comes from the application perspective and retrieves data into application. The name will be covered with 4 axes, even though it's longer than 4 characters. Social security number, I have specified that I have a suffix exposed of 4 letters. So these 4 letters will be exposed. My profit is within range, and they gave me a bigger number, which is nice of them. But my email, Virginia@maskme.net, what happened to my email? You can see that it still belongs to me by the first letter V, but it's not in .net domain, it's in .com. So no matter what I want to do with my email, if I use email algorithm, it will always be .com. So if you have specific reports that you want people to see different based on different emails, domains, you are out of luck either. So if I however try to do certain things, how secure is this algorithm? Let's look at the certain things. So if I just select it, I have some stuff covered. It's pretty secure. It's more secure than any other algorithm because it covers the data with access. It maps everything into just one single value. You can't really know which zip code people live in. You don't know what's their age, what's their gender. You have no idea. However, if you have a sophisticated application or the user who may, for example, use reporting services, and he wants to run and retrieve all the data that starts, the name starts with V, he can easily accomplish that. Let's do that. Even though you cannot see the name, you will know that it starts with V. Even worse, if he suspects that I exist, he can retrieve me based on a direct equality. So selects are not secure, not as secure if they know if they have some hints about the data in the application. They can do certain things to reveal the values. Now, let's look at how we can, what happens with the data when you, let's say, want to move data from one table to another. And for that, I have to revert to a different role, to the one I was before. Revert is not always working for me, so I have to do it several times. And I will drop, excuse me. Okay. I will drop the object that I have, if I have it. Now I've done it, okay. And I created a test copy of the patient table. Right now, what I'm going to do, I will run the data writer to the test login. And executing as a test login, I will select data from test, and I will select data from patient and insert it into test. My test is empty now. And I inserted data from patient into test. Now let's look what happened to the test. When I was inserting data, as it was supposed to be with my current role, I was able to insert data as the protected user. However, again, if I know something about the data content, I might decide that I want to update my social security number. Watch what happens. I just updated it, and voila, it's 333. So if you know that I exist and I decided to update social security even though you don't know it, you can do that. It's not very secure. Now, if you look at the dynamic data masking and you wonder how you want to no longer mask your data for any users, you will use the altered column drop mask command. I have to revert. I don't have a proper context. Okay. And if I drop masked from the name, you will see that I just dropped, because I'm sorry, now I have to be again in the context. Just a second. I will get proper context. Yes, you can see that I dropped just this particular default algorithm from the name field in the social security and social security, profit, and emails still stay masked. All right. All right. So, what are the other limitations, and how do other operations work? First of all, you have to understand that there is a permission associated with the masking function, and it's called any mask. You can give any mask permission to different users, it's appropriate to grant alter any mask to a security officer. Users with select permission on table can view the table data. Columns that are defined as masked will display the masked data. Grant the unmasked permission to a user will enable them to retrieve unmasked data from the columns for which masking is defined. Control permission on the database includes both alter any mask and unmasked permission. There is so now if you're a DBA and you have data masked, backups, restores, selecting to and plain update inserts are all done with unmasked values. Policies have to be enforced. We also saw that selects are not immune. The implementation carries a heavy weight on rendering schema all the time, and it has corresponding consequences to the plans. Other limitations. Masking rule cannot be defined for the following column types: encrypted columns, file stream, column set, or a sparse column that is part of a column set. Mask cannot be configured on a computed column, But if computed column depends on a column with mask, then computed column will return mask data. Column with the data masking cannot be a key for a full text index. You cannot mask files. You can only mask data in the database. This goes without saying. So let's go back to the presentation here and see that, and you have seen that the application developer actually can see the data. Application developer needs to know what kind of data they have to update, insert, and select. They need to run queries with data which is not masked. Application developer cannot be protected with dynamic masking. For that, not application developer. Application cannot be protected from developer with the dynamic masking. For the protection application of a developer from the developer, we use static data masking. But Microsoft doesn't have static data masking implementation. You are on your own. I don't know if you feel happy now, but you might need to implement static data masking, because oftentimes outsourcing happens in development, not just for DBAs and not just for the particularly users. So what will happen is you will have to implement static data masking yourself. And static data masking is a pretty developed field. What you need to know is that it has a variety of algorithms. Algorithms are very well developed. The substitution random algorithm, substitution deterministic algorithm, character substitution shuffling, number date variance shuffle, and nulling are the most used algorithms. So let me cover a little bit of each. Substitution random is when you take a value and you replace it with a value of a similar format and rules. Name will be replaced with name, credit card with a credit card, social security with a social security. But it's not necessarily having access, because it's hard to work with access. You will be replacing it with realistically looking but false value. You will replace it in a random fashion. The application will not know that the value was replaced, and in every particular run, the value can be replaced with a different value. If, however, you want to maintain referential integrity, for example, you may have referential integrity, maybe not on credit card numbers, but you may have referential integrity on account numbers. The random substitution in that case might destroy your application. You would still need to use a substitution method, but you would love to probably maintain some deterministic way of replacing the value with another value. And for that, you will use the substitution, which is a deterministic substitution. And then this oftentimes will work for you, even if you don't have a referential integrity explicit. For example, you may have a person table and a customer table, and both will have the name of a person that came to you as a customer. If I am your customer, you will have Virginia Mushkatblat in one table and in another as well. And when you do a substitution deterministic, my name will be replaced, let's say, with Robert's name in both tables. Then another variant is then you use character substitution, but you don't use it the way Microsoft uses it. You don't map it to XXX. We may always say that A stands for something else. A stands for Z. This is easily decoded, easily reversible. But sometimes application needs demand that it be rather reversible than non-usable at all. You can use harder ciphers than replacing value for value, but you will have to come up with a cipher yourself. You can use another algorithm of shuffling characters within the word, but this one is even less secure than replacing based on a simple cipher. Because it will remind you of the play that everybody played when they were children, when you will shuffle characters within the word, and then you will be asked to guess the right word. For the names, it will not work. Even for the zip codes, it will not work, because oftentimes you will have certain amount of administrator zip codes within specific state, for example. Then there is also number and date variants. They are implemented similarly to Microsoft implementation of number variants. Microsoft is very sufficient in that respect. Shuffle is when you take a column and you shuffle values along the same index in the column. Such a masking doesn't change the values, but at the same time, if you have aggregates function on the column, the aggregates functions are preserved. So there is always a fine line between algorithm you choose for masking and amount of development you can do with the substituted values. And you will have to choose. However, if you properly identify your sensitive data model, the combination of masking methods will provide you sufficient, very sufficient security. There is a myth that you cannot really mask data in such a way that you can't re-identify values back. Actually, this is a myth. If there are no public databases in which person disregarded his own concern for privacy and presented his own values in that database to the public, if there is no such a database or person doesn't participate in such database, his value in the application will be sufficiently preserved. Oftentimes people cite Netflix case when Netflix would de-identify their data, mask their data, throw it into the world, and then another developers would get the data set and re-identify it with another IDBM database presented in the public use. This is very insufficient, incorrect example of the value of unprotected data. The people who don't worry about their privacy and knowing that the other database will publicly expose them cannot demand that the Netflix developers de-identify their data in such respect that their other usage will not be able to identify them within the de-identify set. Basically, if you don't care about your privacy, nobody will. But if you do, then you can demand from the applications that they do as well. Besides, there are a lot of applications nowadays on the market that allow you to mask text data values, because the majority of the identification was based on the text data values. So you have to be careful what you are de-identifying or masking, and take care of all the possible data values of the integrated model. So how do you implement those algorithms? Actually, there are examples all over the internet how you would do them. Majority of them are not very safe. Although you can figure out some specific ciphers that will provide you some significant safety. But I would like to show you how the data masking looks like based on what we do. I will not disclose the algorithms, but you can see how the deterministic data masking actually takes the data set and translates it into another data set. So here we go. We do data masking in SSIS with the series of components. We have a database right now, and one of them is working as the MagicDB, and the other one has a masked table with masked data. One of them is a production environment with unmasked data, and the other one is a development environment with data masked. I will truncate data in the development environment really fast, and then I will use the algorithms each per element, and we will mask data of the patient. And data of the patient looks like this. What we are masking last name, first name, middle name, No, middle name we don't. We are masking date of birth, and we are masking social security number and company. So after you choose every deterministic algorithm, except date of birth, and one of them will use the shuffle, we will receive the destination with masked data. Here we go. How am I doing on time? A little bit over?
We're 4 minutes over at the moment.
Okay, I'm done. I'm almost done. I just want to show the results and show where you can guys ask me questions. While it's running, I'd like to tell you how you can ask me questions besides today. I don't know if we have time to answer questions, if there are any questions, but you can come to us at www.masking.net, and you can click on the request or into contact us and fill the form with the question, and I will be answering them in a very developed fashion, placing the blogs on the site. And this is the site itself, or you can call us. Or send me email at info@maskme.net or virginia@maskme.net. Does that matter? All right, so now we have masked the 20 rows. I will look at the resulting values. And there we go. We have changed, as you can see, we have changed the first name and last name. We changed the date of birth into date of birth. And Social Security preserved the separators, and it doesn't have access. For you as a developer, it's very important. And the employer also has specific values. They were also changed according to the industry. So you will have a variety of algorithms. You will have to either develop them or buy them from the third party to apply the static data masking. And again, you can actually look at the webinar on our site, and it lists some of the sources for how you can look at the open source. But again, the algorithms mentioned are not the most secure. If you are interested, we can do a different webinar on data masking. And I know that I'm not allowed to advertise, so I don't advertise. All right, so I do a little bit. So any questions that we have? And at how much time we have?
Currently, we're 6 minutes over time. There were a few other questions which I answered directly to the people with the answers. I can repeat them if you'd like me to.
No, that's okay if they got the answers, but I'd like to have them so I can post the blogs if they're good.
Yeah, I'll send those to you in email.
Okay, I hope you guys enjoyed the presentation. Send me comments, anything that you'd like. It's a 200 level presentation. I can provide significantly more in depth on the data masking, and Robert and the security chapter will decide if they are interested. And there I will be explaining the algorithms themselves and the k-anonymity and L-diversity and the architectures, if of interest. All right, this is it. I'm giving you the rein.
Great, thanks for your time today, Virginia. We really appreciate this, and I'll be posting the recording this evening on our YouTube channel and upon the Security Virtual Chapter website. Thanks, everybody, for attending.